this video is all about beta decay. So what happens in beta decay is you get a decay of a beta particle, which is basically an electron. So basically no relative mass, but a charge of -1. So we can write it like that. Now, there are two different types of beta particles. There's a positive beta decay and a negative beta decay. We're going to stick to a beta particle being an electron. So we can write it like that, or we could write it like beta. So let's have a look at an example. So let's have a look at this example. So thallium-210 emits a beta particle. So let's have a look at an example now. So if we have a look at one example, thallium-210. So we write thallium-210 in, and we know it's going to decay to some sort of daughter, plus it's going to give us, so we leave a gap, a beta particle, an electron. And whenever we have a negative beta particle emitted, we actually get an anti-neutrino emitted as well, so we must write that in, but it has no relative mass and no relative charge. So 0 and 0, so it's not really going to affect our count, but it is part of the process. It is also emitted during this decay. So then we need to figure out what is going on with thallium, what's the protein count of thallium, and we can look in the periodic table and find that it is 81. And then we need to figure out what is this daughter going to look like. So we can see from the top line that we're going to add 0 to 0 to 210, so that's not going to change. But down the bottom, we have to figure out what's going on down the bottom. So this, again, if we look down the bottom, 81, or the sum total on the left-hand side has to equal the sum total on the right-hand side. So what are we going to write in here? What are we going to write in here? Well, we're going to have to write 82, because 82 minus 1 plus 0 is going to equal 81. So we've actually changed into lead, 82. So thallium can decay with a beta particle, antineutrino, and it will become lead-82 with an atomic mass of 210. And that is how we do beta decay. Let's do one more example. Okay, sometimes you're given the situation where we don't know what the mother is, the starting product, but we do know what the daughters are, and so we can work backwards. So this situation, we're saying we're not sure, so something, so we'll leave a sort of space here, decays to form a beta particle and nitrogen-14. So we can write nitrogen-14 in there, and nitrogen-14, 7. Okay, so then it's going to give us a beta particle. So remember that's 0 relative mass, a negative charge, and an antineutrino, 0 and 0. So what did we start with? So again, we have to balance the top and the bottom. So the top, 0, 0, 14, no change. So I'm adding up. So I'm just looking at what the top numbers are and making sure the left-hand side equals the right-hand side. And then again at the bottom, we need to make sure that this is all conserved. So what we have is a 7 minus a 1 plus a 0. So we're going to get a 6 at the bottom here. Now 6 protons can only be carbon. So carbon 14 will decay with a beta particle plus an antineutrino into nitrogen, carbon 14, 6. And that is how we could sort of work backwards with beta decay.